about the Aikman steering ATV, and I know you guys are using 2D simulation, but in is there a chance in the future that you may consider using 3D simulation like Gazebo?
Yes, sure. We just don't have a model yet, but we could use, it would be nice to have both the gazebo and stage model.
Okay. Well, Gazebo allows you to import model using STL files, so it's a it's a path to look for. Let me start.
So Howard is the team lead from Virginia Tech. They won the autonomous soil sampling competition at the AgBot challenge this last weekend. And their team uses ROS, and they offered to come tonight and give a presentation on their robot and how they're using ROS.
Right. Sorry about I forgot to introduce myself.
No worries.
I'm sorry. Well, my colleague just joined. Hans, hi.
Yeah.
Can you hear me?
Yeah.
Yep. Could you introduce yourself?
Sure. So my name is Ihan. So I'm with Howard, with Virginia Tech. So we won the competition last week, and I was mainly working on software stuff. And I'm a CPE major in Virginia Tech. Just graduated.
Hey Matt, how can I start screen sharing?
At the bottom of the Zoom window, there's a share button.
Oh, okay. Okay, here we go.
At the bottom of the screen, you can also open the chat window and the participant window if you want to see those, because sometimes people will post stuff in the chat window so you can share links.
Okay. This is the repo that I have been working on with the Gazebo model. Hai has a newer repo that he forked from mine, and his repo is put on the presentation during the competition. But I'll also post the link here. But in here, I just want to show you the code that I've been working on. Okay. So this model.sdf is the one that come with Gazebo, and how can I group everything? Sorry, I'm more familiar with Atom. There we go. So this is the original STL file, and then I found a Python file that converts SDF to URDF. It's called pysdf. This one. So it says Python library to parse SDF into cause hierarchy and then export URDF. However, even with this file, the URDF that it output doesn't work right away, and you need to do some modifications. So the problem is with this output, and when I run it in Gazebo, I can see like each part, each joint or each link in Gazebo is visualized or simulated as the entire ATV. So what you're gonna see is a lot of ATVs piling up together, and then you need to go into the URDF file, that converted URDF, to manually modify the size and the position of each component. So this is a cleaned up URDF, and you can see all these joints, like the MU joint is the additional joint. This front left steering, front left wheel, those are the original ones. The ones I added is the front left. Okay, well, let me start like this. So I found, I cannot find a Gazebo model that works with increment steering. However, I'm able to create a 4-bar linkage to simulate increment steering. Like the one showing this picture. The 4-bar linkage is this 4-bar linkage. So if I have this linkage in Gazebo, if I only turn one wheel, the other wheel will follow it. And however, URDF doesn't support 4-bar linkage. So this is what I did. I created 2 additional joint called front left steering rod joint and front right steering rod joint. And then under the Gazebo tag, I created this like front right left steering rod joint. This is the 4 joint that joining up the 4-bar linkage together. This is how you define a 4-bar linkage in URDF and works in Gazebo. And for the link, here are the steering rod left block and steering rod right block. This is the additional one that was not included in the original SDF file. And then let me show you what it looks like. Oh, sorry. There's the word.
So, Howard, while this is booting up, what were some of the advantages of using a gazebo model over just a 2D simulator?
Well, I have been thinking about the same question recently. But what I find is in a 3D simulator, you have the height of the vehicle that you can choose where to place the LiDAR and camera if you have one on it. But I think, I don't know, Hai, could you answer this question?
This is actually a hard question. So, so basically the difference is in 3D simulation, if you have like an obstacle that's lower than a certain height, and then if you place your LiDAR like higher than the obstacle, you will not be able to see the obstacles. But that's actually the only difference that I could think of.
So they call stage a 2.5 simulator because you can put height of objects. So you can put a laser scanner and a camera and then put objects in the height level. It's just that you're traveling on a 2D surface.
Oh, yeah. We actually never thought about the stage before.
Okay. Old school.
Yeah. And maybe in Gazebo, it may be like more convenient to add 3D models. And we actually have detection. And then if we also have the detection node running, we can have the actual image of the camera, which is simulated, and detection can actually like identify objects from the camera, from the simulated camera.
That's a good point. So you can have 3D models of objects inside of Gazebo, and then your camera can do recognition or classification based on that. Yeah,
yeah.
That's a good advantage.
Let me see. Yeah, I can run it. So you can see the wheels turning together. And I'm using a joystick to control it. So before I'm using this model, there is a camera steering plug-in, I think, and it controls the two wheel joints separately. So what happens with that controller is, if one wheel turn and then there is frictions simulated on the other wheel, the wheels will not like turn altogether. One will follow the other with a delay. So you can see the wheels actually turn to two opposite directions when you try to turn from left to right. However, with this 4-bar linkage, there is no problem like that. Let me see if I can zoom into it. Oh. It's kind of slow, I guess. Well, I guess that's all of it. Can you see that? Can you see the white dot right here? Can you see it moving with the wheel? That is the additional linkage that was added to this model. And that's my part. That's the part I want to present tonight. I'm also thinking about isolate or put this HMI steering ATV out from the repo that we have that simulates all the navigation, and then we can maintain it. We can work on it all together, just as a HMI steering ATV. I'll post a link for that. Okay. Hai, could you could you introduce the navigation system we used?
Yes, definitely. So I think you have to turn off your screen sharing in order for me to turn on.
I'm trying. Sorry, I'm really new to this.
I believe it's at the top of the screen. You have to hover over the top button. The button will show up and it'll say stop sharing.
Okay. That works.
Okay. Let me see. Desktop one. When I clear sharing, there are several options. Okay, I think the desktop stands for the entire desktop, right?
I think so. You can share your entire desktop or just a specific window.
Okay. So can everybody see my screen now?
Yes.
Okay, so let me first introduce the GitHub repository. So the one that we shared in the presentation is actually this one. So I forked this from Howard's repo and then made some update. And then here's a node file. This is supposed to be a bash script, but it doesn't work as a bash script anymore. I just use that as like a node for all the dependencies. So in order to run this simulation, you have to have all of these installed. You can just copy and paste. And so let me just start running the simulation. So the simulation can be run by this command. The launch file is called navcontrol.launch.
Can you post that link to the repo in the
Oh.
chat window?
Sure.
Okay. You can follow along.
So don't run this node.sh file. Just copy and paste this. Oh, actually, I think there might be some extra step that needs to be done because this model uses like a gazebo model and then some extra plugins. So I believe we have to add two environment variables to run it. So, and then, yeah, I think that's it. So you have to add like two environment variables. And I don't know why gazebo isn't starting.
The two environment variables are for the map plugin.
Yeah. And gazebo is actually covering the two command. Oh, yeah, there we go. Okay. So you have to add these two to your bash RC. These two lines to your bash RC. Okay, there we go. Let me see if gazebo will start or not this time. Okay. So this is our simulation environment, and then I used both the MapViz and the RViz. So in MapViz, I actually have it to I use a click plugin, and then you can just click anywhere in the map, and it's gonna do waypoint navigation. But for this one to work, you have to send a command to the vehicle to let it start. Oh, gazebo close unspec. Okay.
Are you using a desktop or using the Surface?
I'm using the desktop with the GPU. I don't know why. Oh, it seems to be working. Could be the original. Could be like the last gazebo. So I'm not gonna do the waypoint navigation in this presentation because this is not related. I'm just gonna use the the what is called the move base goal. So I can just publish a goal in the MapViz, and then the card's gonna move. It's calculating. And you can also check on the RViz. And gazebo as well. And I don't have the configuration file included in my repository, so it didn't show the global plan. Let me see, where's the global plan?
I think in RVs, the car you added is facing the wrong direction.
Oh yeah, I know that. Wait, and the MapViz program is actually unstable. It always crashes, and I don't really know why. Oh, there we go. There's the global plan. I set that to the lattice planner, and then I send another goal. Yeah, this is the global plan here. And then as you can see, there's like another green line that is separated from this is the local plan. And this was look like in gazebo. So you guys want to see more, or want me to actually start introduce like how the navigation works?
Curious what size computer you're running this simulation on.
What do you mean by size?
Processors and RAM.
Oh, I think this is i7 2600, so it's actually a second gen quad core.
Okay. Uh-huh.
RAM, I think. Oh yeah, actually my motherboard is broken, so I pull up like 8 gigs of RAM. So now it's only 8 gigs, but I do have a NVIDIA GTX 1060 6 gigs graphics card.
Okay. Okay. So yeah, and so if you're missing 8 gigs of RAM, it seems like it's a little bit slow. Is that kind of the issue, or?
I don't think it's the RAM's issue. The many of these packages are not really well optimized, and because the planning algorithm is actually quite complicated, it also takes some time.
What you're seeing here, what you're showing tonight, is that pretty typical for how it responds and works for you, or do you usually get better performance?
I'm sorry, could you explain the question?
Yeah, no problem. Is this the speed that it's playing for you today on the screen? Is that what you usually see, or is it usually a lot faster?
Yeah, it is actually what I usually see.
Okay.
And I actually use my laptop for development. It's a Surface Pro 5, and that one doesn't have a dedicated graphics card, so I'm seeing basically one FPS in the simulation.
Gotcha. Yeah,
And,
good. Thank you.
yeah, you're welcome. And yeah, my laptop gets extremely hot when I'm running this.
Yeah.
Yeah, this could be a problem if you want to deploy this like simulation everywhere. Let me just introduce the what I did to get the navigation to work, but I'm not going through the entire PPT.
Okay.
Wait, actually, I don't think this is the latest one.
Oh, right.
Yeah, here's this is the latest one. Let me just find the actual meat part of this presentation. So what I did is, so in our like a typical ROS navigation stack, you have all of these things. Any of you are not any of you not familiar with ROS navigation stack? No one? So everybody knows how ROS navigation stacks work. That's cool. So basically, in a typical ROS navigation stack, you have all of these. You have the localization, you have like odometry, you have also Costmaps. You have this way of setting the transform. But in our case, we have the GPS. So, and then we didn't read odometry. So what we did is we made transform look like this. How do I see better? Just download this. Yeah, and ignore everything in the bottom. This doesn't matter. These are not important. But here, the map, the word map and ODOM frame, I made them all in the same frame. So in the original, like the navigation stack, the local planning is done in the ODOM frame, but now both the global and local planning are done in the map frame. And the only transform that we have to publish ourselves is from base to one of the three. And this transform is published by the GPS. And I also used a GPS common package. So in the GPS common package, it provides a UTM odometry. But the UTM odometry has like really huge numbers. So what I did is every time I start the simulation, I will just use the current position as the origin. And then as the car moves, the odometry will also increase. So that's how I publish the transform between the base and the map. So now we have I constructed my own odometry, which comes from the GPS, and it is centered at the origin. And that's it for the transform. Any question about the transform?
So world and map, those are just static transforms?
Yeah, these are published by static transform.
Okay.
Any other questions? Okay, let me move on. So
your heading, does your GPS output heading?
Yes, so our GPS, as we mentioned in the presentation, so it is a Novotel system. It uses both the IMU and GPS, and it fills both. So it has the heading information.
Okay.
Well, in the simulation, the GPS and IMU are separate units. They're using separate topics.
Oh yeah, right. I forgot that. Yeah, so in the simulation, we used some plugins to get the GPS and IMU. And in this transform tree, the rotational transform is provided by the IMU, and the translational transform is provided by the GPS.
Okay.
But in our actual system, I can just get both the information from the same topic, so we don't have to do that separately. But in the simulation, we do that separately. And so the next thing I did is sorry about that. So next thing I did is I used a package called Tab Local Planner. I think many of you are pretty familiar with this. It's a time elastic band. And then I can show you guys my configuration file for this.
We have Teb running on our simulator, but haven't got it working on a real vehicle yet.
Yeah, and this is actually what happened like when I was testing the car only with the tab installed. So the planning actually works pretty well. This local planner. So this is the configuration file that I used for our robot. This is gonna be different for basically like any other robot that we use. But in our robot, there are like some specific property that is only that that is only like correct in our robot. For example, these two.
Were you ever getting like oscillation errors and timeouts?
Actually, no, not that much.
Okay.
The only problem that we have is the reverse problem, because like I said, the time that's gonna take for us to make the car to go reverse is gonna be too high. We cannot afford time to build a mechanism to shift the shifting sticks. So that's the reason I used another global planner. But for now, I'll just keep talking about this. So this is the setup that we use, and then there's the interesting optimization parameter called the forward drive kinematics, and this actually does nothing. Yeah. This doesn't like eliminate the reverse behavior at all. So and the algorithm says it ignores it when you choose the Ackermann steering option.
Okay.
Yeah, another thing that we tried is to decrease the penalty epsilon, but that doesn't seem to have an effect. And actually, this algorithm runs extremely slow on default. Because it treats each obstacle as a point. So we also use a converter, Costmap converter. Let me find the configuration file for that. Oh, there we go. So I use this specifically. So this basically runs ransack and then convert all the obstacle to polygons. And I can just show you. So let me publish a goal, and when that's running, you can see all these obstacles are converted to polygons. Can you see the red lines here?
Yep.
Yeah. So and let's see what else about the tab. I think that's it. And then I can show you how I did the transform. So in this package. So in this node, I published both the transform and the odometry topic here. So I called it fake odoms because it's actually fake. It's from the GPS.
Mm-hmm.
And what I did is I just get the LMU, and I use whatever when the program start as the origin, and then I just do a minus. Just do a minus the current value. That's for the translational, and then the rotational is from the IMU. It's pretty easy node, but I do use a lot of global variables. I can turn that into like classes to avoid using global variables, and that's it.
And that creates your ODOM to base link.
Yeah, this creates both the ODOM topic and the ODOM to base link transform.
Okay.
Yeah.
I was using GPS pose.
What is that? Is that a package?
Yes, it takes in your IMU and gets the heading from that, and then gets your GPS, and then publishes your ODOM, and also publishes your transform.
Oh, that's exactly what I did. I should have used that package.
Well,
If I know that. Yeah, if I know that's available. And let's go back to the tab local planner. And I also decreased the goal tolerance actually pretty high now, and the yaw goal tolerance I increased that to like more than 3.15 because we don't care about the direction of the goal at all. And then minimum obstacle distance. Actually, I think I set that to 2.0. I just I didn't merge that properly. This is supposed to be 2.0. And for the vertices, we define the polygon for our robot. And we also decrease the loops, the number of iterations. I think we also decreased that. And maximum number of classes, I think the default is 4. I could be wrong, but I think we also decreased that. So I made a bunch of tuning. Now the algorithm runs much faster. So before it was running like 60 seconds for a loop. Now it's like 0.2 seconds.
That's excellent. I've never heard of that Costmap converter. That's a really smart way to do that.
Yeah. So if you don't do that, like the independent variable is going to be a lot. So the program actually treats each point in the Costmap that has a high occupancy as a point obstacle, and that is extremely inefficient. So after the Costmap, so actually most of the speed gain comes from the Costmap converter, and the rest are just like small tunings. And after that is tuned, so our robot can just basically avoid obstacles, but still going backward. So I actually set the backward speed to this number. And actually the algorithm discourages that, but sometimes you can notice that the when it wants your robot to go backward. Actually, let me see if I can show that in the simulation. I can just comment out the global planner, and I can show you guys what it looks like when it wants to go backward. So if I comment this one out, it's gonna use the default NavFN global planner.
Mm-hmm. I've got a question on your M prime file too for your AgBot, how you generated that for your lattice planner, but we could get to that.
Oh yeah, the M prime file, the primitive file. Yeah, we'll get to that.
Okay.
So actually, that file takes me like most of the time. I was losing sleep before the competition trying to generate the file, because you have to know, like, after each subsample, like will each discrete state connect or not, and I don't think that is like possible for human brain to easily calculate. So I think we just use the default one and do some like cost tuning. And I think this should be the NavFN behavior. So if I let it to maybe go backward, you're gonna see that it wants to go reverse. It's not that clear here, but maybe more clear in MapViz. Yeah, now it's gonna go reverse.
And because you set your max backward speed to such a small value, your robot never moves, and so
yeah, exactly.
It's a good workaround.
So in the simulation, the robot can actually go backward. If you set the backward speed to some other number, it's actually gonna go backward, but in practice, it's not gonna work. So as you can see, the curve is actually changing. So if you the function is, if you wait long enough, the curves, like the curve that does the backup is actually gonna disappear. The robot is actually gonna move forward. I think that's because the algorithm itself, because it's called time elastic band, I think they also take time into consideration. But I'm not exactly sure like why this is happening. And that is just my guessing. So enough of that.
Hey Matt, I have a question.
Yeah,
Yep.
yeah.
The lawnmower you guys are working on is able to go backward, right?
Yes.
Okay, so will this tab local planner work with your robot?
Well, Tab does work with the robot, and it does make it go backwards.
So going backward that is not a problem with the robot.
No.
Okay.
But the only problem you said is you're getting a lot of oscillations, right?
Yeah, we'll get oscillation, timeouts, and then yeah, just a lot of failures, planning failures, and can't do trajectory errors.
Okay. Well, that's really strange.
But I think it's the global planner. If we use this, we use like this SPP lattice planner for the global plan to do, instead of the global planner doing like a differential plan, just twist and go, it gives it a nice arc to follow. It may cause less problems with the local planner. That's a guess. I'm not sure exactly what's causing the problems.
Okay. Do you think you configured all the like the vehicle properties properly? I think like the wheelbase and the minimum turning radius.
I doubt it.
Okay.
Go back and look at those.
Yeah. So I think what I found out is if you configure those improperly, so like for example, you expect your vehicle to have like a minimum turning radius, maybe too low, like lower than it actually can be, and the algorithm figure out that you're not following the plan, it might like replan the path, and that might lead to like oscillations.
Okay.
Yeah. So after that, I added a algorithm. This is the lattice planner. So
So you just took the mprim file and then just used that and then adjusted your.
actually a little bit more than that. I don't have MATLAB on this laptop. Let me see if I can connect to my desktop at my home. I'm actually not in my home now.
Yeah, I got stuck. I don't have MATLAB at all, so I wasn't sure how to make that file and get everything configured.
Yeah. Let me have a look. Let me try to show that. Oh, I click cancel. Now I have to type everything again. What? Okay, whatever. Let me just go to his GitHub repository and find the source code. So I run this. Actually, the reason why I use this is from a post in the ROS forum. So a guy mentioned he's using a differential drive robot and accidentally used this file. So this file prevent any turn in place motion. and then he found out his diffuser drive robot is not turning in place. So I used this file. The only thing that I changed is the backward cost multiplier. I changed that to a really high number, and the side step cost multiplier, also the turning place multiplier, cost multiplier. So I actually tried to change all of these. So I basically draw a little Cartesian coordinate, trying to figure out like what this number should be. We're running our robot like when we have like the turning radius of 4.8 meters, and I couldn't get this to work because I'm always having a roundup issue. And then I also so the global map resolution that we're using is 0.5. So I should also change this number. And then I generated this file. Yeah, actually, as you can see, I actually generated a bunch of them, but I forgot which one that I used. Yeah, this one that we used. So this is the final version. I didn't touch all the states. I just kept them the same because I was getting error all the time. So this is what I used. And after that, the global algorithm is able to guide the robot to go around. And the time that Tableau Planner lets the robot to go in reverse basically is really small. Like the chance of that happening is really small. So I can just make it go a really hard maneuver. So now it's facing at this direction. I didn't change the direction of this image. So,
Yep.
And as you can see, the lattice planner is able to make the robot go around. Without this global planner, the Tableau planner is gonna make the robot go in reverse.
Yep.
And that's basically all.
So
anyway.
You have to have MATLAB to convert that M file to a prim file?
Yes.
Okay.
But I think for experimental purpose, you can. Oh, actually, I don't think the original file is gonna work because the original file have really high map resolution. And a bad thing about the MapViz package is you cannot set a goal that is larger than the global Costmap. And then for local Costmap, you can get that to roll with your robot. You can set that to rolling window. But I don't think, so I tried that with the global Costmap and it doesn't work. So the global Costmap seems to be in a fixed position all the time. And then for this small number of resolution, you can only get like several meters or maybe 50 meters of length before the algorithm gets like before the computation gets too complicated. So
what's a good number to put in there for the resolution?
So so my resolution is 0.5.
Okay.
You can see my planner. Yeah, this is the global planner. So I use 0.5. So now our robot can move within a 500 meter by 500 meter rectangle.
Okay.
I think I tried like 2000 by 2000 and it still be able to run like not that slow.
I think MATLAB has a free trial for 30 days. You can
Yeah.
just MATLAB free.
Okay.
So any question? So any more thing that you want me to go over?
That's a lot of work. That's impressive. You guys did a great job.
Yeah, thank you. Yeah, it is a little bit time consuming.
We actually figured out the latest planner after we arrived at the competition site.
Yeah,
A lot of late nights there.
yeah, I lost a lot of sleep.
Hey Han, I have a question for you. This is Arjun.
I'm sorry. Your mic is a little bit like your volume is a little bit low. I can't really hear you.
Okay, I'm sorry. Just a second. Can you hear me now properly?
Yeah. Go ahead.
Okay, so why did you mention that you were using Tableau Planner, right?
Yeah.
So did you face any trouble with, I would say, weird controlling of your robot, like HEV? Mainly, I'm talking about the steering control.
I'm sorry. I don't understand. Could you go over that again?
So I'm talking about you. I went through everything about what you were talking about, the Tableau Planner, which you use for autonomous guidance, right?
Yeah.
So I did the same. In the meantime, I was facing a lot of steering jerk all the time. So did you guys ever face that situation ever, or you guys did not?
Oh, do you mean like the robot isn't able to follow a straight line? Is that?
Yeah, absolutely, yeah.
Oh yeah, actually, we had this problem, and then the solution that we figured is actually the acceleration limit for theta.
Okay.
This number, make this number really small. So this number means how fast can you turn the steering wheel. And if you make this number too large, it's gonna turn the steering wheel really fast, and
Okay.
that's gonna make the robot not be able to follow the straight line. And I was having this problem in the simulation, both in the simulation and in our actual robot. So so after we found out this this problem, we set the number to a really small number, and then everything is solved.
Okay. Yeah, I can try that. Thanks a
Okay.
lot.
You're welcome. You're welcome.
Yeah, really good stuff. Thanks for the demo tonight.
Mm-hmm. You're welcome.
Any general comments on the AgBot challenge? What do you guys think? What should we do differently next year? Or Howard and Han, you guys are done for next year.
Well, I have a bad news that we're not gonna do it next year. Well, at least from Virginia Tech, because our faculty advisor has too many teams to manage, and he decided to cut out some teams. So Aqua is one of it. Second is I'm going to grad school. I need to focus more on my research. So, well, this year I supposed to supervise a team instead of working on it myself. But in the later in the semester, I figured there's a lot needs to be done, and mostly related to control and electronics, which requires a lot of experience that my students don't have. So I basically put aside my project and start working on iPods. And my professor was not very happy with it.
Yeah,
So,
takes a lot of time.
yes. So we're not doing iPod as Virginia Tech for next year. However, if you or Rosag allows me, we can work with Rosag and go to iPod next year.
That would be awesome. We'd love it. That'd be cool.
Thank you.
Soen and Kalyan and Arjun were there at the AgBot Challenge. Any comments or thoughts?
I
I don't know if you've already shared this, but yeah, having printed circuit boards is the next plan.
Mm-hmm. Yeah.
Matt had a lot of trouble with disconnected wires. So
Yeah. In our design, we soldered the headers onto a prototype PCB, and then we used connectors that has a lot like a lock mechanism. Like it's like a plug, so everything will stay in place. That's what we did.
Yeah, definitely robust wiring is important. We barely got the robot driving autonomous missions, I think about 10:30 that night before. So.
Well, another story. Our onboard computer's hard drive failed the night before that competition.
Wow.
It took us like 2 hours to figure out this hard drive problem, because when we reinstall Ubuntu on it, it crashed again. So we found that it's a hard drive problem, but luckily we have another laptop has a another SSD, so we put it on, and that laptop is already running Ubuntu, so we don't have to reinstall anything, and we just reconfigured everything and it works.
Wow.
We got lucky.
Yeah,
cool.
actually, the configuration part is actually longer than the installing.
Well, same thing happened last year with the watermelon harvester.
Yeah.
Bring spare parts and plan for a lot of work, I guess, is the thought for next year.
Yep.
It's a lot of fun. I enjoy it. It's cool being out there and fun watching the robots run around.
It is.
For me, this was my first exposure to AgBot Challenge, so it was really fun to come there, watch everybody showcase there. And there were a lot of teams which presented cool stuff, different teams. For me, what's fascinating is definitely the technology was very fascinating, but also like the struggles every university had to go through, every other group had to go through. Forget about winning the competition, just to get there and make it happen. It was just fascinating to see everybody get there. In fact, I was thinking, like, how did you guys drive that ATV all the way from Virginia Tech to here on the boat, or did you guys ship it? Like, I didn't understand. Like, how did you guys get that?
Well, you see the Penske truck.
Uh-huh.
The Penske truck is belong to us. We rented it, but we drove that truck over here. Everything was in that truck.
Oh, okay.
Yeah, but we also are able to just click a point on the map, and the car will eventually go there because it has the navigation functions.
So technically, it can go from. Yeah.
Ultimately, we will be there.
One day.
Maybe next year.
Yep.
Before I run out of gas.
And we also need to move the base station.
Yeah, I think one thing which hit core to me with your presentation, I don't know who was saying that, but somebody said that we need better project management to make sure that we hit all this in the right notes. I think was it Howard, you say that, and I was like, this competitions definitely need a little bit more project management to make sure all these things are taken into account and make sure that people are not spending last minute, night outs the day before the competition to make that happen.
Yep, that's right.
We're running a little bit over, but Howard, Han, thank you very much. Congratulations on your win. A very cool robot.
Very
Arjun,
cool.
nice seeing you
Thank you.
tonight.
Nice to see you. Actually, we really like to participate and contribute to LOSAC. So I think, well, at least me, I don't know about Hai, but at least me, I will start joining the weekly channel. I'll at least try my best to join the weekly channel meeting. Start from now.
Excellent. Glad to have you, Howard.
Thank you. And
Yeah,
I'll
we would
try
love that.
if
We would love to have your subject matter expertise here. You might ask, at least me might ask some dumb questions, but yeah, we would love to have you guys and take us to the next level in terms of subject matter expertise.
Thank you. It's also a really good opportunity for me to join LOSAC.
Yeah. I will also begin to join the weekly meeting whenever I have a time.
Fantastic. Feel free to join if you got time. Stop by. We'll be continuing to work on the lawn tractor, and hopefully we'll get it better for next year.
Okay.
Great. Well, I hope you guys have a fun week. Thanks again for being here, and we'll see you on the Slack channel, if not next week.
All right.
Great week, guys.
Have a good one.